This discussion will present the behavior theorem. The behavior theorem is a theorem that you should have memorized and should be able to quote, and you will use it often. We will be sketching curves, and every time we sketch a curve, you will use the behavior theorem. And what we're going to do is just kind of illustrate where the behavior theorem comes from. We're not going to prove it in this little clip, but we will illustrate it. Let's look at f of x, just some random function f of x, and let's try to imagine tangent lines that are 0. Where would the tangent lines have a slope that is 0? Well, lines with a 0 slope are horizontal, so we're looking for horizontal tangent lines. Where would f of x have a horizontal tangent line? Well, we can easily imagine that there'd be a horizontal tangent line there and there. Now, remember that the derivative of a function, is itself a function that, if you put in an x value, it gives out the slope of the tangent at that x value. Well, so therefore at a and b, the derivative of f would be 0. Now let's try to imagine tangents that are positive. Where would f have positive slopes? Where would the tangents of f have positive slopes? We notice that all of the tangents to the left of a would be positive. And all of the tangents to the right of b would also be positive slopes. Well, that means that the derivative would be positive as long as it's to the left of a, and positive as long as it's to the right of b. But we see that in between a and b, wouldn't all of the tangents be negative? There's a negative tangent, here's a negative tangent, here's a negative tangent. So all of the tangents between a and b would have negative slopes, hence the derivative, which is just a function that spits out the slope of tangent line, would be negative between a and b. And from this, we get the behavior theorem. Notice that wherever the derivative is positive, like for instance from negative infinity to a, and then also from b to infinity, that's where the derivative is positive, is where the function is increasing. We have an increasing function here, and then again starting at b, it increases thereafter. But wherever the derivative is negative, from a to b, the function decreases. That leads us to the statement of the behavior theorem, which we will state here. Okay, we're going to state the behavior theorem. Here we go. This is a theorem that you should memorize and be able to employ. Be ready to quote and state and use. Suppose we're talking about a differentiable function f over some interval a to b. Okay, then the behavior theorem says, here's the part, if you're going to cut it down and memorize just a chunk, this is what you memorize. If the derivative is positive over an interval, then the function increases over that interval. If the derivative is negative, this is code for negative. If a number is less than 0, it's negative. If it's greater than 0, it's positive. Anyway, if the derivative is negative over some interval, then the function decreases over that interval. That's the behavior theorem. Memorize it.